Alright, let's start. Hello everyone, welcome to the stream. Today I'm gonna continue where we left off yesterday. Yesterday we managed to render this guy here. We're generating a voxel image based on an image input. So we're loading an image and then generating voxels based on the pixels on that image. And our little guy looks like this right now. And first I'm gonna do a little bit of code cleanup. Since the way I'm generating that mesh isn't too great. Let's see. Basically, I'm generating a mesh and then I have to copy the mesh into the render commands buffer, and then again in the platform layer I am copying that mesh again into the GPU, so there is one additional copy there that I could get rid of. So that's what I'm gonna do next. So when adding a mesh command here, I made it so that I'm allocating the memory out of the render commands buffer. But in case I already have a mesh, I don't want to allocate from the render commands buffer, and instead I wanna just give it the mesh. And I think that should be fine. I could just... I'm gonna write a new command for that. Where I just supply it with a mesh. That actually can be passed by value. Where is the mesh? Is that... No, that can be passed by value. That's fine. Or constref, it doesn't make a lot of difference in this case. Do you need to return something? You don't need to return anything. In this simple case, we're just gonna set the mesh member of the command to what we supplied it with. So in this case, we're not copying any memory, and also we're not allocating the vertices out of the render commands buffer allocator. But the size has to be 0 in this case, since the size should have the number of bytes we allocated out of the render commands allocator, and in this case we're not allocating out of that allocator. Okay, now if where's my mesh stream? Let's have a convenience method that turns our mesh stream to a mesh. Let's put that here. How does our mesh look? Vertices, indices, and then counts. Vertices, indices. Our mesh stream is very similar to what a mesh itself is, but it also has a capacity, since we can stream geometry into the mesh stream, and the mesh itself is static. And the render commands Pt.1 static meshes. So that's why we're writing a converter here. This works, but this assumes that we know that the layout of the mesh is always the same. Let me write this a different way. This way we can move stuff around and it's still gonna be initialized correctly. Same for indices. And then we should be able to just like this. So this should basically be the same thing as before. Yes, it's working, except we're doing one copy less now. So I like this notation a lot more. One other thing was I can also allocate the mesh stream out of the render commands, which I was where is it? Mesh stream. This here, this one. And I didn't like how the mesh stream guard works. So let me first change this to the way I want it to work. So this should take a pointer to the stream. This should compile. Except now we need to change the dot notation to an arrow notation. Did it work? Yes. Right, this should be still working, yeah. So one thing I didn't like about the notation before, let's say I'm using this one, this command here. I want to write this. Let's say the color is green. So I just generated one green cube with what I wrote, but as you can see, what this thing does is it returns an object of the type mesh stream guard, which is this thing, and it does some memory repositioning on its destructor, since we don't tell when we generate the stream, the geometry stream, the mesh stream, we don't tell it how many vertices and indices we're gonna consume. So there's a lot of unnecessary padding at the end, memory that we didn't use. So it's gonna move the indices to where the vertices end and make it so that our memory, it basically defragments with a single move. Where's my move? With a single move command. But for this to work, I have to always put this in a block like this, so the destructor always runs here, and the destructor has to run before I can issue new commands. If this was a C code, I would write something like begin mesh stream, and then somewhere else should be begin. I would write something like this if this was C, and I wanted to have something that uses C++ functionality, but it kinda makes the code uglier, since to get the stream itself, I have to write stream.stream or guard.stream, which isn't nice. I wrote an implicit conversion operator here, but it's not very useful since I want to have a pointer as the first argument of this function. So instead, I'm gonna make it so that we are never gonna call directly into this function. I want to have something like this. Let's see. So we're just starting a block where we stream meshes. We're gonna tell the block what the name of our stream is, and then the renderer from which we are gonna allocate the stream. And afterwards we are gonna use it like this. And it's just gonna work. So I want something like this. So this has implicitly, it uses the begin and end block statements. We're using the constructor and destructor of this thing here, but the object we have access to isn't this helper struct, but the stream itself. That's a lot nicer of a syntax than this one here, since this is error prone. Since if I forget to put this in a block and issue more commands here, this is gonna corrupt the memory, or just run out of memory. Yeah, it's gonna run out of memory because the mesh stream consumes all memory, and then it releases the memory at the, when the destructor is called. So this this syntax is a lot nicer. And now I have to figure out how to write this macro, probably. Oh, let's keep this name. Let's change this to, it's an implementation method. We are not gonna call into it directly anymore, so we don't make this mistake. Define nice stream block name and renderer. Okay, this kind of looking weird, but the idea is I want to have a couple of scope variables, and I want to have a block following the macro. So the block following the macro I'm managing by doing for loops that only get executed once. For it let's see, because I need a variable called once, I need this if construct here that defines this variable, so I can access it in these two for loops. And then we have one for loop for the guard and one to get the stream out of the guard itself. The guard is one of these things. At the beginning of the first for loop, you're gonna call its destructor, and once this block is finished, you're gonna call its destructor automatically. And this should be just working as it is. Yeah, we compiled. Let's see. I didn't set the color, so the cube was just white, so we couldn't see it. So this should output a green cube. Yeah, there it is. And this syntax is a lot nicer, and we know inside this block, the mesh stream block, we can't issue a renderer command since we're right in between a renderer command. I could enforce it. In fact, let's do that. So that the renderer is locked while we're in this mesh streaming mode. Where's my render commands? Right here. I like to write isValid functions whenever I'm dealing with pointers, and this also makes it easier to add additional checks that need to be fulfilled. So we ensure that this render commands pointer is in a state that we can work with, and I'm just gonna say the render commands is only valid if it's not locked, and all of my uh, functions that add commands to it always check whether the render commands is valid. So that small change will make it so that we can't add additional commands while the renderer is locked. And then in the constructor here, we're gonna set it to locked. Except this doesn't take the renderer, so let's make it take the renderer. You can access allocators through the renderer, so we're just gonna change this argument to the render commands structure itself, and then we can say that it's locked. We're gonna assert that it's not locked at the beginning. Hi Polarado03, welcome to the stream. And then we're gonna release the render command structure at the destructor here. And we're gonna assert that it's locked. So right here we're gonna not, we need to change this argument. I'm working on the renderer. Let's see, do I compile? I can show you what I'm working on in seconds once I get this code up to date. I'm working on rendering voxels basically and generating geometry for voxels. This needs to be this. Alright, we're compiling. Does it work? Okay, I'm re-enable the voxel rendering so you can see how it looks right now. It's nothing special. We're just generating a voxel mesh from a simple image. So it's a 2D image that looks 3D. And I'm gonna make this volumetric today, since it's kind of flat right now. And for that to work, I need to work a little bit more on my mesh generation, which I'm doing right now. So the nice thing about this notation is all the memory management is being handled by this block itself, and I can just push a bunch of bunch of voxels or cubes, and this should just work as it is. Let me change the color so we can check. Yay. The 2 green cubes, 2 blue cubes. And I should actually be also able to render the voxel mesh as it is, and additionally do this too. Sure, go ahead and ask your question, Palaradu. And this is working also. So one of the things I am not doing right now is the mesh we are generating isn't optimized. This I'm gonna implement once the voxel editing is working a little bit better. So one of the issues is you're generating faces inside the voxel that you're not gonna see from the outside, and as you can see, there's a little bit of Z fighting there. So those faces wouldn't even need to be generated since we can't see them. Okay, this I tried to make a little Rubik cube in C++, not in 3D, only the console, I think you meant there. For the moment, I try to work on the algorithm, and I have decided to use a matrix 3 by 3 by 3 to represent each little cube of the Rubik. I don't really know how I can generate the good color of each cube. You see what I mean? That is a good question, since I have no idea how to do that. There, let me think about this. The Rubik's Cube has different properties depending on where the cube is located in the 3 by 3 by 3 matrix. Since the center ones aren't, they are fixed. And the, let's see, this is your cube, right? So the center ones, here they're fixed. They only have one face and they can't move. So I have no idea how to represent that. And the ones right here only have two faces. This and this one. So I guess you would store a 3 by 3 by 3 matrix. Right? And then you would use flags, I guess. Something like this has top face, and then you populate it. It's definitely not easy handling Rubik's cubes. I have no idea how to do that. I would do a lot of reading if I want to implement something like this. I'm pretty sure there are a couple of Rubik's Cube simulators out there that you can learn from. I personally have no idea how to do something like that. Currently, I would have to think about it a lot. Definitely not easy. You mean I have to manually put the color of the face of each cube? Definitely. You have to keep track of um, which color each face has currently, and how a move changes the colors on the cube. Since you can't, I think there are predefined moves that you can do on a Rubik's Cube, like rotate the top like this, or the right column here like this. And then you just have to make sure that your representation is consistent and coherent after each operation. And you need a way to check whether the cube is solved. And that's it, basically. So the representation is, you can use whatever you want as long as the operations you do on the Rubik's Cube is reflects its true state. As long as you don't make a mistake and your representation is consistent. Okay, let's get rid of these here. Next thing is, right now I'm generating the voxels from an image, and instead of doing that I want to generate voxels out of a 3D grid where I can say for each cell whether it's filled or not. And then I'm gonna generate the mesh out of that. Let's use, this is a pretty big grid. Well, not really, but should be fine. And then we need a way to tell it what kind of cell. How the grid is filled. It can be empty or solid. Although I need more information than that, since maybe color information and texture coordinates maybe. Not quite sure, I'm just gonna work this solid for now. Let's see, how would I do coloring information? Or do I even need that? I'm not quite sure yet. Let's move these above the game data structure so I can use that. And then I'm gonna change this algorithm where I'm generating the geometry from an image to generating the voxel grid from the image and then generating the mesh from the voxel grid. So I'm gonna separate it into two separate steps. Okay, let's assert that we have an image and that the grid is valid. We're gonna fill the grid with the empty value. And then we're gonna iterate through the image. And we're only gonna fill the first Z layer of the voxel grid with image data. We're not gonna use the rest for now, at least. We're only gonna set the cell to visible if the pixel was visible. If the alpha value is 0, we're not gonna generate voxel. And I'm not quite sure how I'm gonna implement color yet, but first we're gonna make this work. Then you're gonna iterate through the grid in a 3D fashion and generate cubes. That's x plus y times Is that correct? To get to the next Z layer. So to get to the next line, so our grid looks like this. It's a 2D grid per face, but then it extends in the Z direction. So this cell here is 0, 0, 0, the top left one. To get to the next row, you have to increment the pointer by the width. So in this case it's 4, but in our case it's 32. So that's how we get to the next row. But if you want to advance in the Z direction, so go one deeper, let's say you are at this cell and you want to go to this cell over here. So go one next to it in the Z direction. We need to go uh, 4 by 4 in this case. You need to advance the pointer by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So in that case we get right here, which are the dimensions of the width times the height in the X and Z direction. And that's how we get to the next Z index. So this calculation is correct. Let's put these in parentheses so it's more clear. And maybe write it like this, so it's clear where these numbers come from. And only if the cell is solid we're gonna generate the mesh or the cube for that particular cell. The color is a to-do, since I'm not sure how to encode the color into the grid yet. We're just gonna set it to black for the beginning. This just assumes that each cube is 32 by 32. I could pass the size in. I think I'm just gonna leave it like this for now. Okay, this should do it. Okay, now I should be able to replace this code with the new version. What did I call it? Just voxels. Generate mesh from voxel grids. This is the old code. Doesn't quite compile. Oh no, it does. These are just warnings. We don't use this yet. Cannot convert. Okay. Yes, so now we're generating the voxel grid and we're generating the geometry, but we are not encoding any color information, so the whole mesh is black. But by having a voxel grid and a mesh representation, it allows us to manipulate the grid and then also change the mesh by doing that. So I'm gonna make some voxel editing, very simple voxel editing, by just manipulating the grid. Then afterwards we're gonna save and load them from the models from the from storage. We're gonna save them to files, and the last step is actually then we need to optimize the meshes, since the geometry I'm generating is not optimal yet. A lot of unnecessary faces. Okay, so the color issue. I think I'm not gonna do the color encoding yet, since I'm pretty sure I'm gonna change the representation of the voxel grid a lot, and I'm not sure whether I want to have color information in the voxel grid. I'm pretty sure I'm more interested in texture coordinates, so we're just gonna leave it like this for now, and instead I'm gonna implement voxel picking through the camera. I basically want to know which cell of the grid I'm looking at right under the mouse. So when I'm pointing the mouse at it, that I can select the cell. So the first thing I need for that is I need to know the projection matrix. And I think the game layer doesn't have access to it yet. I store the project, let's see. the projection inside the platform layer, I think. Yes, the OpenGL context has a projection, and instead we're gonna move that to the game layer. Render command, so each render command is gonna store a projection. And the view, world view projection. Do I need to store them here? Yes, I need this matrix. Definitely. So we're gonna store them here so the game knows where they are. We need access to them. And we're gonna change the platform layer to use these matrices instead of storing them inside the OpenGL context. Projection. So this changes to wait, I'm not using this function anymore. Let's comment this out for now. Right here it is. Exactly, I have access to render command, so I have access to the world view projection. Let's do it like this. This should compile, yeah. And we need to set the projection in game now, not when we initialize OpenGL. Yes, let's take these out. Don't need this, don't need this, and don't need this. Okay. It's compiling now. Instead, let's do the projection stuff in game. We're setting up the camera here, the renderer, and then we're gonna set the matrices. Make render commands. Initialize the matrices with the identity. And then in the game initialization, we're actually gonna fill that with the proper projection. The width and the height. Does the game know about the width and the height? Not yet, so I have to pass these in. Viewport width and viewport height. So when initializing the game, we're gonna pass that in. Although we don't have a window yet, so And if I did everything correctly, the game should look just the same as before. Yes, it does. Okay. So once we have access to this matrix world view projection, we can basically take array from camera space and convert that into world space coordinates. So let's say our camera is right here. We're looking like this in this direction, right? This is our view, and this perspective here is the world view. Since in game we're looking out from this view, but this illustration is in world view. And what I'm interested in is this ray here in world space, so that I can feed that into this grid, which is also in world space. Otherwise I would have to transform the whole grid into the view space, and that is a lot more complicated. So the ray starting position is pretty easy. It's wherever our camera is. And the ray direction is just the wherever our camera is pointing at, which is called camera look. That is the direction in which the camera is pointing at, and this is the position the camera is currently at. Wait, isn't this already in the vault space? Yeah, it is. I'm already storing the vectors in vault space. I didn't need the matrix. I'm just realizing this. Normally you would take these vectors and then do something like transform take the world view projection and then transform them into the world view space. But I think I'm already storing them in that format and then generating the matrix from the camera. So I don't need I didn't need the matrix, I think. Okay, so we have the ray, which is fine. We can just work with that. But then we need the algorithm, which there is a paper about that algorithm. I have a link right here. So let's take a look at it. This paper is pretty interesting since it's from 1987. It's pretty fascinating that they already knew how to handle voxels way before they could actually render them efficiently. So they're using array just like here, just defined. Traversal algorithm consists of two phases, initialization and incremental traversal. The initialization phase begins by identifying the voxel in which the ray origin U is found. That's easy. If the ray origin is outside the grid, we find the point in which the ray enters the grid and take the adjacent voxel. Okay. The integer variables x and y are initialized to the starting voxel coordinates. In addition, the variables step x and step y are initialized to either 1 or -1, indicating whether x and y are incremented or decremented. Okay, this makes sense. So in 2 dimensions, the algorithm would look like this. And in 3 dimensions, it looks like this. What are Tmax and Tmaxy? Okay. If I understand this correctly, let's think about this in 2D for a second. So we have a grid here. So first of all, we need the starting position of the ray. Let's say it starts here. And it goes like this. The T delta x value is how much we are moving along the ray to get to the next intersection with the grid boundary in the y direction. So this is T delta x. So if you're here, how much do we have to move along this ray to get to the next intersection? And as you can see, for each intersection with these lines, the vertical lines, it's always the same length. So that's T delta x. And the same thing happens with the y intersections, the x intersections, these here. Coincidentally, these are almost at the same space. So the next one would be here. And these have T delta y. Or maybe the names are, let's see. No, but the names are different. This is x, and this is y. I was wrong. This is y, since we're getting intersections with the y-axis here, and this one is x, since we're getting intersections with the y-axis. we're calculating the intersections for each step. We know how far along we need to go along this ray to get to the intersection. Like in this case here, the x intersection comes before the y intersection. That is this check here. It checks which one comes before the other one. So the x, if the x intersection comes first, we set that to the new Tmax, and then the step along the ray to the intersection. We go through all intersections. These store the current cell we are in. These are integers, and these are t values for the ray. So this is t0, and next voxel is basically a callback in this example to notify, hey, we visited this cell xy. Okay, let me do a new illustration just to make sure that I get it. Let's do 3x3 for now. So let's say again our starting cell is this. So the x value is initialized as 0 and the y value is 3 or 2, 0, 1, 2, yeah. The ray goes like this, and then we calculate the y intersection and the x intersection, which is this one. We compare these two and know that the t value for this intersection is smaller, so we know the y intersection comes first. Which is called x in this case, since whenever we are crossing the y-axis line, we are moving to the next cell in x direction. So this should be red to make it clear. So whenever we are crossing a vertical line, we are moving to the next cell to the right. That is what this is. X equals x plus step x. Which means the current cell we are in is this one, and then we notify the code, hey, we visited this cell, we are now in this cell xy, so the game knows, okay, we're here. And then from here, this is the new ray starting position. We calculate the next two intersections, which is the intersection with the horizontal line and the next intersection with the vertical line. And this time the horizontal line comes first. And in this case, we know you're visiting the next cell over. So we're in this case, we increment y, and then tell the game, hey, we're in this cell. So we would be visiting the cells in this order. This is 0, 1, 2, 3, 4, 5, etc. So the first issue is we need to know in which cell the ray starts at. And in most cases, the ray won't be inside the grid at first. If the grid is like this and the ray is outside the grid, if the ray starts here, we have to first find the point where the ray enters the grid. And I don't think they're telling us how to do that. Or are they outside grids? We don't need this paragraph. Well, they are using the algorithm to find out at which object the camera is looking at. But I'm actually using Voxel, so I'm not placing objects into a grid. But the grid itself is the object, so I'm only interested in which cell I'm looking at and not at which objects inside that cell I'm looking at. So this is what these paragraphs are about. The equation of the array is U. Okay, this is exactly how we're storing the array. The new traversal algorithm breaks down the array into intervals of t, each of which spans one voxel. Yeah, that is t delta x and t delta y. Start at the array origin and visit each of these voxels in interval order. If the ray origin is outside the grid, we find the point in which the ray enters the grid and take the adjacent voxel. Okay, but where does that take place in the code? Well, let's just try it out, I guess. Struct ray cast result. It's gonna return the x, y, and z indices of the cell we found. Ray cast into voxel grid. To the voxel grid, ray origin and ray direction. we're just gonna return the first non-empty cell we're gonna encounter, and also we're gonna return the normal. Well, I don't know if we can find out the normal of the face we're looking at, but it would be nice to know which face of the cell we're pointing at. Since each cube has 6 faces, we want to know which face. So the first step is change ray origin to be inside of the grid, or find first grid intersection point. Well, in 2D it's easy. In 2D I would just the same with the algorithm itself. I would get the first y intersection point and the first x intersection point. Let's see. I would just consider the edges of the grid if the origin is outside the bounding box of the grid. And then I'm just gonna calculate the intersection points for each edge in 2D. It would be this one, the extension of this one, and if we extend this one, the other intersection would be here. We would get a negative t for this, since we would have to go backwards through the ray to get to this intersection. We would get 4 results, and I would pick the smallest positive t value. And that would be our grid enter position, from which we then do the raycast. I think. In 3D, this is pretty much the same thing, right? So for each dimension, this check here gets 1 level deeper. So there is a top level check for x and y, and then instead of just stepping through, like here, they do another check for the z-axis. So let's use the bounding box for that. The bounding box of the grid is pretty straightforward. It's at 0, 0, 0. No, it's at 0, 32 times. Let's store the cell sizes somewhere. Okay, so this way, cell count y times cell height. That's the top position of the grid. So my coordinate system is like this. This is x, y, and z goes up like this. Positive z, positive y is here, and the grid is positioned like this. So the bounding box, the top left position of the bounding box is 0 x, 0 y, but the z position is, oh, this isn't z, this is y, this is z. The y position is the cell count times the cell height. So there are 32 cells here until we reach the top of the grid. And the z position is 0. And we need the right bottom far position, which is this here. It's this time the y value is 0 for that. And cell count z times cell depth. So this is the grid bounding box. So we're not using this yet. Let's find the position in which we are entering the grid using the ray, origin and ray direction. But I know how the loop works. Where is the calculation for the t deltas, t delta x? I understand the algorithm, but the math behind it They're, they don't seem to be telling it. Hi General Soak, yeah, I can link the paper. It's there you go. So I can just check very easily whether the ray origin is inside the bounding box. Which isn't very very interesting. This would be the simplest case, since if the ray origin is already inside the bounding box, I can just calculate the cell by dividing the position by the cell width, height, and depth, and I would get the starting indices of the cell. This case is simple, but the else case isn't. Let me just make sure that my math is correct, that I can just check whether the ray origin is inside the box, like this. Generate. So let's change this to accept the color. Or maybe no. I'm gonna do that differently. Oops, I can't do that. So if we are inside the bounding box, I'm just gonna set the color of the vertices to green, and otherwise I'm gonna set it to red. So I know that my math is correct in this case. Vertices count. Right. So if I go inside the grid, no, never changes to red, green. Should be inside the bounds right now. Hmm. Let's make sure that we have valid data here. Yep. If you have a link to it, you can link it in the comments. I will take a look at it. Thanks. Oh, so for some reason the mesh is in negative space. Still. Yeah, right now I should be inside the bounding box. Oh, then I'm so sorry, General Sog. I disabled uh, linking in the chat. I should have put you on the where is that? Yeah, I should have permitted you linking for a couple of seconds. What is the command to untimeout something? Okay, let's take a look at it. Thanks for linking anyway. Raycasting, ray start, ray end, vector of visited voxels, that's fine, and the t values. Get voxel ID from position ray start, current voxel. Yeah, that is what I'm trying to find out. What is get voxel ID from position? The Delta x, okay, sorry. Let's see delta x. Oh, here. So it's the bounds. Okay, it's bounds divided by the direction in x times step x. It just says whether we're advancing in the positive x direction or negative. Okay, I get that. Can you link me this one? So this is what I am struggling with, the ray, to get the first cell from the ray origin. This one I bin size. Oh no, this is cell size, right? Not the grid size in total. Yeah, this seems to be the cell size. Okay, I get it. Yeah, thank you, General Soak. This is raycasting. Let's see. There is get voxel ID from position. Oh, I get it. Of course. Yeah, I was just saying, if the ray origin is inside the grid bounding box, since in my case the grid is bounded, I could just calculate the current position by doing exactly what you are doing here. But if I'm outside the grid position, I would just get negative indices, which is fine since I could just raycast into the grid until I get positive indices. And once I hit the first positive value, I know I'm inside the grid. I don't even need to do that. I know how often I need to increment in a given direction based on the value that is negative. So if I'm starting at -5, I know I need to go 5 at least 5 cells in the x direction to even begin um, colliding with the grid. Okay, so I guess I don't need this check. Actually, I think I know how to implement this now, kinda. But there was this one bug here. My bounding box check doesn't work since my voxel mesh doesn't change color, even though I just implemented this thing here. So let me see. Does this ever return true? No, I should be inside the grid right now. Yeah, my guy is upside down because let's see, y start is okay. I should be inside the bounding box right now. Why isn't this returning true? I am inside the bounding box. Okay, what is this point inside? This check is true. This check is true. This is true. This is true. This isn't true. Also, this is not also not true. I think oh yeah, this assumes that check assumes that the coordinate system is like this, where the positive y values go down and my coordinate system is set up where the y values go up. I'm thinking about whether I should use this coordinate system or in 2D I'm always using this coordinate system where the positive x goes right and the positive y goes down. And I was just thinking about extending this by allowing z values, which would be this coordinate system. And if I did this, then this check would be correct then. Otherwise, I could just set up the bounding box differently. Alright, now the bounding box check works. This is right at the edge, so okay, good. So this isn't needed anymore. Back 3i, I should have a I version. Yes, I have. Okay, starting. Actually, I'll be right back. I have to go really quickly to the toilet. I'll be right back. Alright then, alright, let's look at this. I'm just gonna assume for now that we're already inside the grid. Just to make debugging easier. So the delta x basically is just the movement in x direction divided other way around. The width divided by the movement in x direction, which tells us the t value of how much we need to advance in radial direction to get to the next intersection with. Except, let's see, is the width there correct, or should that be the y? Where was the intersection? Right here. No, it's the in x direction. That's correct then. Oh, I skipped a step. The step x. Which is just a sign. No, sign bit is stupid because that takes -0 into account. Why are you multiplying with step x here? Isn't this just gonna make t delta x always positive? Does it need to be positive? My colleague wrote this. Okay. Yeah, I think it does assume that it's positive, since otherwise this smaller check would always have to keep would have to be flipped if the sign was different. Yeah, so yeah, that makes sense that this needs to be always positive. I'm missing the max values. Distance until next intersection with voxel border. This is the current. Oh, this is just the adjacent voxels in the respective direction, but why multiply by the bin size? Um, oh, these are the initial values. This, okay, I think I know why. This is because if you're um, inside a cell, the first intersection is less than t delta x or y or z. Bin size is your cell width, height, etc. Yeah, I understood that already. I think I already did the calculations, just like here with the bin size. And here, yeah, it needs the values as not cell indices, but actual distances to the next voxel. Okay, and this is the initialization code. Okay, I get it now. Um, except he's saying there isn't. No, there is always the next boundary, but there might not be Tmax if the direction in that the value in that direction is 0. In that case, it's gonna be set to the max. Okay, I get that. Voxel y. Oh yeah, these need to be relative values to the gray origin. If current voxel is not the last voxel, what is this doing exactly? So if the directions are negative, he's moving the current voxel 1 to the left or down. Why is that? Not sure. Okay. We know in which cell we are currently, it's this one, so we can check whether that cell is full. If it is, we can just return directly. Let me write a utility function for that. Hi, Pt.1. Like this. Oh, so this one is taking up the position of where the ray ends. I'm just telling it a normalized float Tmax. So this is the selection radius. Now I have to select the min of the three intersections. So x like this. These are the 4 cases. In the case Tmax x was the smallest, we're gonna increment in the x direction and increment this by the delta for the next intersection with the x boundary. Does that make sense? Yeah. And at every step, we're gonna check. Actually, let's do that here. After we incremented our position, this is the same here. Okay, this should make sense. Let me change this check to be not empty instead of being solid, since um, I might add more than one voxel type per grid. So my viewing distance, let's say it's 1000 units. In fact, let's add a new type which is selected, a new voxel type, in which case I'm gonna change its color. Where do I generate? Right here. We're just gonna call this whenever we find one of the voxels. First I'm gonna turn each voxel to unselected, and then the voxel we are looking at I'm gonna set to selected. Oops, I don't need to do this. to the cell we found, we're gonna set to selected. And otherwise all of the mesh voxels are red. Wait, didn't I check whether I was inside the bounding box? This didn't return? No. Why didn't it return? Here at 0, 0, 0. Okay, yeah, that's fine. Oh, we're inside the bounds, but we're looking outside. So we're right at the edge of the grid, and we will never intersect with any of the cells inside the grid. So that's the bug here. The easy fix for that is just to check whether the coordinates are inside the cell bounds, and otherwise we're gonna return false. Oh. Out of memory. Right, I'm not clearing the stream. Um, should be working. Oh, my mouse is locked. Let's see. Let's step through here. Let's see. To be end up outside the bounds before finding a non-empty cell. My code is the same. Step C, delta Z, yeah. Yes. Bot91 wants to know, get cell. This line here, right? So my voxel grid is just a one-dimensional array, and I'm mapping three-dimensional coordinate indices to a one-dimensional array, and that is what this is doing, this line. Cell count x is the cell count in the x direction of the grid, and this should be y. I can explain that to you in a second. Let me try to debug this first, please. This time we're going out of the x values. I think these might be wrong because of the way my coordinate system is set up. So the ray is looking in the minus z direction, that's correct. I'm looking a little bit up and minus x. No, this is correct. The step x is correct. All of these are correct. Why am I not hitting a non-empty cell? Is my grid correctly initialized? Yeah, some of them are non-zero. So no matter what I'm doing, I'm not never, even when I'm right inside a cell, if I'm right inside a cell, am I not in this one case? My mouse is locked. Shouldn't I be here? No, why not? What does this return? Okay, we're gonna stand right inside the cell again. There it is. I'm definitely right inside the cell right now. Yeah, z value is 0. That means this should definitely not be empty. So the index is 800, 834? Y is 26. Okay, that could very well be 32 times 26. Grid data index is 0. What is right in its vicinity? It's all 0. They're all 0? That doesn't make sense. So the y value is way too high. Oh, now I get what my problem is. Okay. So my coordinate system is like this. This is x, this is z, and the y coordinates go up. But my grid is set up like this, where the 000 cell is this cell here at the top left, and the y coordinates go down in the positive direction inside the grid. Which means the coordinate systems are wrongly matched. And the cells I was checking were always empty because of that. Because I was checking the completely wrong cells. This problem again, I think I'm gonna make this mistake very often because I'm just so used to the y values, the positive y values to be to go down. I think I'm just gonna switch the coordinate system to be like this instead. And then I'm not gonna do that mistake anymore. Although I probably should I switch the I'm gonna leave it as it is for now. Okay, the problem is step y is correct. Wait, is it? If I'm looking down, the step will be negative, but inside the grid it will be positive. It needs to be positive since the coordinate system of the grid is different. Yeah, so this needs to be flipped. And this is also wrong. The grid begins at this position. If I'm here, I need this distance in positive. So this needs to be flipped like this. Then the y value is correct. The right direction. Maybe it's more useful if I just do this instead of flipping. Wait, I did just return true. Why am I not? No? Oh, well, it's clearly wrong. Hmm. Also, it's always the same cell for some reason. Oh, it's moving with me. That's interesting. It's not the direction I'm looking at. Kinda is the direction I'm looking at. Hmm. It doesn't work if I'm looking down, but it kinda works if I'm looking up. That's a weird bug. Why is me moving up and down affecting this? Is it really thinking I'm inside? Now, if I'm inside the cell, it actually works correctly. It's always kinda green. No, this one's black. This is the wrong cell. So me looking down doesn't do anything. But if I look up, this is weird. What is my ray direction in that case? No, this is completely fine. I'm looking slightly to the right. Or left in both directions. Hmm. So your coordinates are wrong. Maybe you mix up the x, y's, and z's. But let's see. Does it think I'm inside the cell? No. It really calculates the cell by doing this loop here. But I probably did something with something wrong with the coordinate system. Well, this one I checked against the code. That is pretty much the same. Let's see. X, X, Z, Z, Y, and Z again. Yeah, it's totally the same. I'm never advancing this T, by the way. That's definitely wrong. But I don't think that matters, since I'm always checking whether the current XYZ is inside the voxel bounds. So the problem is probably, so is this wrong? Me changing the sign of the Y? Shouldn't be. But the calculation for this is probably wrong. Yes, this is the problem. It's again coordinate system. I think this needs to be this way, because the y-axis, oh, by the way, this should be y and this should be z. Oh, I did mess something up really badly. Why? Okay, let's undo this and check again. I did mess up my x's and z's. Y, height. The rest seems to be okay. Right. As I'm moving up, the selected cell goes down, so I think there still is a mess up here. I think I was right in the idea to switch this around. Why isn't it taking the y into account? It says the y position is 1. Yes, it's 1. 0 is this row, 1 is this row. And I probably am, well, yeah, I'm at 1. So the y position calculation is correct, but the looking direction is incorrect. I am switching the sign of this because Me looking down in world coordinates means the y value is negative, but inside the grid, me going in this direction means I'm increasing the y. So me switching the sign should be correct here. This calculation is correct. But this Tmax y seems to be really big. And I think that's because I have to recalculate the origin based on where the grid begins. This one. Okay, if I'm outside the grid, I'm not doing any checking right now. And it's kinda offset weirdly. I think that might be what these were fixing, these checks. Yeah, the offset issue is now gone. So that was why that those ifs were in there for. Alright, this seems to be working. But if I'm outside the grid bounds, I'm currently just exiting this one here. That's why I can't select anything in that case. If I'm outside the grid bounds, I have to basically not exit until I'm inside, except if I can never be inside the grid. If I just get rid of this check. Yeah, it still won't work because of this one. I can change these checks to just start checking once we enter the grid, but then I need to do this so we don't loop forever. Oops. Sometimes works, sometimes doesn't. Oh, I also messed up the when I'm inside. It sometimes doesn't work inside the bounds. Yeah. Could be because my max viewing distance was too small. 1000 units. Okay, that was the issue. Although there is this offset issue back. From this direction, the offset issue is like isn't there because of those if statements. Right, from here it's perfect. If I go down, it's also fine. But if I get closer, yeah, the offset issue comes back. For some reason, it doesn't like the cell in the middle. It's for the whole row. From far away, it's perfect. And from the backside, it's also perfect. Although no, it's not. It's still jumpy. Might be this one. I think that's introducing a weird bias towards some directions. But there is an offset now. So the problem is the offset isn't always there. It's only like if I'm looking at this cell, it only jumps to the one below. So fixing the offset, that's why it was jumping around the some of the axis some of the time. Because the offset isn't always there. This offset, how am I gonna fix this correctly? I don't think this should happen in a mathematical sense. There must be an issue with these calculations. In a 2D sense, if I'm here and I'm calculating the intersections like this, is there an offset in this case? Like if this cell was filled, intersecting here, I would already know, yeah, I'm returning the cell. Are you casting floats to ints instead of using floor somewhere? The only place where I'm casting using floor, the only place where I'm casting floats to ints is here, and I'm using floor. Otherwise, I'm doing integer calculations and float calculations completely separately. So there isn't any casting here. So might the floor be the issue? No. If I did do implicit casting, like, let's see, I should get a warning, like here, conversion from float to int. I didn't disable those warnings, so if I was doing some implicit casting, like this position is an integer position. I'm just truncating here. These aren't floats. Well, I'm not truncating at all. I'm just reducing the size. Otherwise, the same thing here. I'm not truncating. I can make it explicit. These are all floats. Internal static void asks what libraries are you using. I'm using stb image and SIMD math library, which you can find in the description box under the stream if you're interested. These if checks, they only fix the offset problem in certain cases. Like if I'm looking at the model from this direction, it works perfectly, kinda, although this is wrong. But from this direction, it's not perfect. It kinda makes it seem like it's fixing the problem, but right there, it's still there. So what else is different here? It's normalizing the array. I already used normalized vectors, the ray direction. Mine is already normalized. So this is, I'm already doing all of these. So the if statements I also implemented now, and it's still off. This is completely the same. This is just bookkeeping. Is your normalized function different from theirs? Well, if it's normalizing, then it shouldn't be different. Is there the definition somewhere here of normalize? No. Well, normalize, if it's doing what it should, it just, well, maybe I have the bug in my code. Let's see, vector normalize. Right here, taking the length, taking the square root of the length, and then dividing by the length, or the reciprocal, and then multiplying by 1 over length. And it returns the array in it returns a vector with the length 1. Can I check it? It's kinda close to 1. Let's see, the math library I'm using is kinda, since it's SIMD, it's not as precise as calling the C library versions of these functions, so maybe it's because of precision loss. No. Well, there is definitely precision loss, but it's not because of that. Visualize the crossing points. That's a good idea. Also in your tvec2 union you use template class T and not template type name T. In that case, class and type name is the same, doesn't make a difference. Type name only has a secondary functionality in certain cases. Let's do this differently. The problem with visualizing is if I visualize it as it is, the geometry I'm generating will be just in the direction I'm looking, so I have to freeze it somehow and then move around to see. That's what this thing is doing. Yeah, then need to spy. Export. Okay, where do I start stepping? This case doesn't count. Right here. And then I need something where I'm freezing the mesh, debug mesh generation. F is key pressed. Oh, I should be rendering them also. Well, definitely trying to render something. Let me disable that assertion, since running out of memory in this case isn't that bad. It just means I'm gonna stop. Oh, they're right. Also, they're completely wrong. Let me change their color. Let's use blue. What? Oh, my visualization is wrong. These need to be relative to the grid. Wait, no. To the gray origin. These need to be relative to the gray origin. And the y value needs to be mirrored. Almost. Why? Let's see. Pause. Where are... Oh, they're going in the wrong direction. Still going in the wrong direction. Oops. And coordinate systems, why are they so hard? Oh wait, I know the t value. I'm a dummy. I can't calculate the position like this. Except this is probably also wrong because... Oh, maybe not. Let's just... Kinda? This is looking... Ah, the y is mirrored. Minus... Again, the thing with the... no, the y... Something with the... I think I'm gonna change my coordinate system. This is confusing me way too much. Me looking up changes the cubes. But the t values are completely useless. Or maybe not. No, this is correct actually. Yeah, y is somehow not up. It's because the grid local coordinate system is like this, where the positive y go down, but my world coordinates are like this, where the positive y go up, and that's why there's this constant confusion whether to negate the y or not. And oh my god, I think the easiest thing is just to be consistent with the coordinate systems and always use this one. Unbenannt, German detected. Exactly. Although I'm using t values, the y it shouldn't. Oh wait, I negated the y here. Alright. Okay, this looks like how it should be looking. Why is there this big um, there should be a cube at this intersection point. Why isn't there a cube at the intersection points? This time there is. Also, what's up with these gaps? There's definitely something wrong. These gaps are way too big. I don't think it's the mesh generation that's producing these gaps. Since I have enough memory to generate cubes up until here. Alright, there's the thing on the intersection point. But there isn't a cube at the exit intersection point. Am I generating too few quads? That can't be. Also, I should be continuing to generate cubes after I already found the intersection, since I'm returning at that point, which means these t values are probably wrong. Make the blue thing smaller, sure. No, I think the bug is with my t values, because I'm definitely stopping generating these cubes after I found the cell I'm looking at. But as you can see, the cubes continue, which means the way I calculated the position based on this t is wrong. But it shouldn't be wrong. Tx, tz, ty. These deltas are based on the ray direction. So definitely that t should be correct. Let's only generate a cube if we find the position. And let's see if it's far out or not. Where is it? Well, now I'm not seeing it. Oh, there is one. Oh, where did it? There. And it's mega far out. So definitely t value. Why is the t value wrong? The code he uses t pushback. Well, if you look at what this thing selects, it selects whatever the smallest out of these three options are, which is the same as putting this pushback inside the if cases here, since you're already selecting the smallest value, which I'm doing. Like he uses pushback, right? I could do this. Set it equal to whatever the max currently is. Oh, you know what? That probably fixes it. I think I was mixing the deltas in the wrong way. That fixed it. Oh shit. It's getting late. Let's see. Okay, we're not mismatching the t values anymore, but Okay, there is one at the intersection point. And yeah, the ray calculation is completely correct. Like, see, we're entering the right cell and exiting the right cell, but this cube got generated even though we already entered a cell that's occupied, as you can see. So why did this cube here get generated? Let me see a case where the offset is wrong. Let me also freeze the selection code. Okay. Okay, in this case, the offset is clearly wrong. Freeze. Alright, this ray is completely off. Interesting. Are you correctly updating the targeted cube? I think so. Okay, the weird thing is, I think there are a couple of issues here. First, my mouse was targeting this cube here, above the green one, but the ray shows me actually targeting the cube below the green one. And the green one is only selected after we enter a cube that is occupied, but for some reason we're not selecting it. Then we're entering this cube, which is green, but we're still not selecting it. But just as we leave this green cell, we're selecting it. See, this cube, which gets generated as we leave a cell, actually causes us to select this cell. So there's definitely something wrong. Yeah, it's a 1 because the ray leaves, but from a mathematical point, the paper actually wasn't designed in that way. It's supposed to select the grid which we are entering as we are entering it, the cell. Move your check in the beginning of the while loop. This check. What is this guy doing here? Let me disable this offset thing here and then see what happens. Okay, now we're actually selecting the cells the blue line intersects with instead of offsetting. But this blue line doesn't seem to be aligned with my mouse cursor at all. Except no, in this case, clearly this blue line is somewhere completely different. And also, wait, what is this guy doing here? So we're actually advancing to this point, and afterwards we're selecting the cell. That doesn't seem right. Okay, the bug with the offset is, I'm convinced it's related with the ray leaving bug. Why is this cube getting generated? Right, is it because I moved it above? No, still. The cube positions are right, but these are wrong. These step things. Since I am visiting the correct cells based on this ray, for instance, this ray is entering and leaving the cell at the correct positions, but I'm selecting it only after I am here. I'm pretty sure it's a really small fix, but my head is kinda not in this case. Again, we're entering the cells and exiting the cells at the correct positions, but we're selecting the completely wrong cell. So me bookkeeping the cell positions is definitely wrong. These lines. Let me look at the paper. So if x is the smallest, no, they're doing the same thing. It's definitely the same. Maybe it goes backwards through the ray depending on the direction. Backwards through the ray? Well, one issue is I think the ray doesn't start at the middle of the camera, it starts at the bottom of the camera and goes in the camera direction. So there is one issue with the offset. As you can see, my mouse, there isn't a cube in the center of the camera. It's the ray starts from the bottom of the camera, which is fine, but there's definitely a additional cell selection bug, since this ray is nowhere near the cell. Also this cube. Oh wait, that cube is one too many, because we're going past the cell, generating this cube, and then breaking out. But moving this check to the top of the loop doesn't change it. It makes it seem even weirder. Like there's still a cube here. Even one more than that. This is so weird. Okay, let me look at this from the other direction and see what happens. From this direction. Still. The ray is completely correct. Entering, leaving correctly. There are 1, 2, 3, 4 iterations too many. And then we're selecting the cell. Like how? Okay, these calculations. Next voxel. No, this should be correct too. The deltas. No, we're leaving. Oh, I didn't do this check. But we're leaving the cells at the correct positions. Let me just also do this check then. These two cubes don't make any sense. The gap in between them is also way too big. Like the gaps here are alternating. They're always the same. Except this one is a horizontal intersection, this one is a other way, this is a vertical intersection, horizontal, and then here begins another cell, here again another cell. This is, well, these two cubes. Let's generate the cubes like this and see. Now the exiting cube shouldn't be generated anymore. Also, why is the offset now so much bigger than before? So the entering cube gets added, but the exiting cube isn't there. So where does this cube come from? T is initialized with 0. Ray origin times T. This cube it always gets generated. It's one too many. No idea what's going on. In this case, the row cube is gone. Let me try being really close. No, it's here again. Also, the exiting cube now is missing. Oh, because I moved it here. Cool. This is taking way longer than I expected. Now we're generating one too many cubes. Also this row cube, for whatever reason. XYZ initialization is wrong. And then the final cube's wrong. Okay. So my world coordinates, again with this coordinate system. Like at the beginning of the game, I'm always in some minus position, looking at the mesh in this direction. Floor is always rounding towards minus infinite. Is that correct? Let's say I'm in this cube, which is I commented it out. It was in there, but it's still wrong. Like clearly we're selecting the wrong cube here. I also think these checks shouldn't be necessary from the math of it. Right, let's say I'm at negative 0.5z, positive x, and positive y. The coordinates I'm gonna be calculating here are 0 for x, which is correct. For y, since the grid y is like this. It's gonna be 31 if it's correct. That says that actually. Let's see if it's 31. Where am I? Let me go slightly to the right and move it up. You're right, I can compute XYZ from my intersections. Right, so the t-values are always correct. That's true, the t-values are always correct. Actually, this is the t-value. You're calculating one t-value too many. So if I do this, alright, as we're exiting. Yeah, now the t-value is just as we're exiting, and this row cube. But to calculate the cell, the exiting intersection doesn't give me the cell. It gives me the cell right behind it. Which means I need to keep track of what the t-value was before the current one to get this one. So this, since our t-values are right, it means, yeah, these are wrong. That's the only explanation. I'm not, yeah, like I said, I'm selecting the cell after it, which means right now I'm basically just throwing things against the wall and seeing what sticks, which is not something that's too. You're busy. I'm adding voxels now. Okay. Well, that is something I wanted to actually add at some point. This doesn't seem right. How are we still getting... I'm calculating the position from the t-value. Alright, so coordinate system switcheroos. My mind is not working correctly right now. I have no idea what I'm doing, so I think I'm gonna stop the stream now. Thanks for watching and sticking with me, especially General Soak for helping me with the code. I really appreciate it. Thanks for that. But I don't think I'm gonna make any progress right now with this code. Yeah, I think I need pen and paper and think this through. And I think this calculation here is something. This this ad hoc converting of coordinate systems is definitely messing something up. Yeah, that's on the to-do list for tomorrow. Definitely tomorrow we're gonna make this voxel picking work. If you're interested in that, please tune in tomorrow. And that's it for me for today. Thanks for watching. And that's it for me. Bye.